Okay, so let's start with a really big question. What is our universe actually made of? Well, forever, we've said it's matter and energy. But what if the deepest layer of reality isn't stuff at all? What if it's just information? We're going to dive into this seriously mind-bending idea. Is information as real, as physical, as a rock or a star?
This whole radical idea was captured perfectly in just 3 little words by the legendary physicist John Archibald Wheeler. It from bit. Now the it, that's everything. Every physical object in the universe. And the bit, that's the most basic piece of information you can have, a simple yes or no, a 1 or a 0. What Wheeler was proposing was pretty staggering, that the physical world itself actually emerges from these simple little informational questions.
So right there, that sets up our central mystery. Is reality, at its core, based on tangible things like mass and energy? You know, the stuff we've been studying for centuries. Or in some kind of cosmic twist, is it all just built from a massive collection of yes or no answers, making information the true foundation of everything?
To figure this out, we can't just philosophize about it, right? We need to follow the clues, look for some hard evidence. And it turns out, the first pieces of that evidence started to connect the abstract world of bits and bytes to the very real, concrete laws of physics. Our first major clue comes from a guy named Rolf Landauer. He proposed that information isn't just some abstract idea, it's physically tied to thermodynamics. Landauer's principle basically says that whenever you erase a bit of information, like, say, resetting a 1 back to a 0, you absolutely have to use up a tiny but very real amount of energy. And that energy gets released as heat. So yeah, deleting a file literally makes the universe a tiny, tiny bit warmer. And this isn't just a vague concept. What you're seeing here is a precise physical formula, KT-ln2. This equation tells you the exact minimum energy it costs to erase one single bit. For the very first time, we had a measurable bridge connecting the logical world of information to the physical world of energy and heat, a physical consequence we could actually calculate. Okay, our second clue takes us way out into the cosmos, to the most extreme objects we know of, black holes. Physicists Jacob Bekenstein and Stephen Hawking discovered something really bizarre, a black hole's entropy, which is basically a physical measure of how much information it holds, isn't determined by its 3-dimensional volume, which is what you'd totally expect. No, instead, it's proportional to its 2-dimensional surface area. It's like all the information about everything that ever fell in gets smeared across the edge, across the event horizon.
So now we've got 2 really powerful clues that suggest information is physical. But you know how it is in science. Just when you think you're getting somewhere, these clues don't actually solve the mystery. Instead, they lead us right into a huge, profound paradox that strikes at the very heart of physics.
So here's the paradox. Stephen Hawking also figured out that black holes aren't forever. They slowly evaporate over trillions and trillions of years by spitting out radiation. So if all the information is stored on the surface, and that surface is slowly shrinking and disappearing, what happens to the information? This creates a massive problem, because a fundamental rule of quantum mechanics is that information can never be truly destroyed. Ever.
And this is where the contradiction becomes crystal clear. Look, on one hand, you have fundamental physical things like energy and charge. They're conserved right as you see on the left. You can't create or destroy them. But then you look at information on the right, and it doesn't seem to play by those same rules at all. We create information when we write a sentence, and according to Landauer, we destroy it when we hit delete. So if it's really physical, why doesn't it act like it? And just when you think it couldn't get more confusing, the plot thickens even more when we leave the cosmos and turn to life itself. Because biology introduces a whole new, tricky layer to this puzzle, the problem of meaning.
So it turns out we're dealing with 2 completely different kinds of information here. First, there's what's called a Shannon information. Physics can handle this just fine. It's all about quantity, how many bits are in a file. But then there's semantic information, the meaning and the function of those bits. A strand of DNA doesn't just hold data, it holds instructions to build a living thing. And this is where physics just hits a wall, because all of a sudden the arrangement of the bits matters way more than just counting them.
So this is the crucial point. Our current laws of physics can tell you exactly how many bits of information are coded in your DNA, no problem. But what they can't do is explain why that specific sequence of bits creates a conscious living person, while a random jumble of the exact same number of bits just produces meaningless static. It's like the difference between a random pile of letters and a Shakespearean sonnet. Physics can weigh the paper and count the ink, but it has no language for poetry. That meaning is completely invisible to our laws of physics.
So when we bring all these clues together, it leaves us in this fascinating but really puzzling place. We've got physical evidence connecting information to energy and to black holes, but we also have these deep paradoxes about whether it's conserved and a total inability to explain what it all means. It's pretty clear we're staring at one of the biggest unsolved mysteries in all of science.
And the stakes for solving this are absolutely enormous. Understanding the physical nature of information could be the key to unlocking everything, from the nature of consciousness to a unified theory of quantum gravity. It might even show us that the universe itself is, at its very core, one giant computer processing information.
Which leaves us with one last, really provocative question. What if space-time, the very fabric of reality, isn't a stage where things happen, but is actually a vast network that's processing information? What if we're not just living in the universe, but we're actually patterns of information running on the universe? The case is nowhere near closed, but all the clues are pointing to a reality that is far, far stranger and more deeply interconnected than we ever imagined.